So here is the architecture overview with stateless applications running on OpenShift with a backend running on IBM. And this is a set of tools we're going to use: Git, Jenkins, Ansible, for managing this hybrid environments, VM-based and microservice and containerized-based applications. Here is my VS Code environment, and I'm going to use VS Code, and I could have used, as I said, RDI to develop either the open source, I would say, and open source applications and the ILE applications on IBM. In that case, you see all the Java code and the Liberty configuration files, and I added some information to say to the application, to the containers, I'm going to connect to the IBM Db2 for I, and I'm going to use even Db2 Mirror for I with an alternate server. So in case of failure on the primary node, I'm going to be redirected on the secondary node automatically. So this is a configuration I did on the customer service microservice, the part that is going to run on OpenShift, right? A Liberty-based application server running in a container. So this is the code, and I'm in that code. So you can easily build this code externally, or you can use a source to image functionality available in OpenShift to do this build. So I'm going to log in to this to the OpenShift portal. I'm going to access my particular project. In that case, I've got my microservice-based application, my AcmeAir Airlines application with several microservices. This is the topology front. So there is the web UI, there is the flight service, the authentication service, etc. And there is in the middle a customer service which is backed by my IBM backend system. And this is the status of my customer service. So it's okay, it's ready. So yeah, I mean it's a loosely coupled architecture, right? So each component microservice is independent, right? So some of them are relying on MongoDB open source on Power on OpenShift, and others are relying on IBM. I'm going to log in just to give you an overview of how it looks like. So when I push this button, it's gonna automatically query my Db2 database because the password is somewhere on my Db2 database, the customer password, because my CRM, this is where my CRM is running, and I've got all my customer information. This information this information is stored on Db2 so automatically, so I'm running my microservice on OpenShift, but behind the scenes the customer service is using Db2 So I'm gonna, so yes, this is I'm using then the flight microservice to book a flight, for instance. I can do that. I can have a look to the so this is really I would say a technical view of the application. And you see the MongoDB-based services with my customer service, which is relies on Db2 I'm gonna then different features, functionalities, and I'm gonna simulate virtual users, and what is what they're gonna do in a loop: log in, modify some customer information. In that case, it will be done on Db2 behind the scenes, and book a flight, check in, log in, log out, etc. So I'm going to play with, and in a loop, I'm going to simulate virtual users using JMeter. I've just updated something on my Db2 database. So what I can do now, from my IBM standpoint, I can use ACS, connect to my one of the nodes that is used by this customer microservice, and I'm going to use an IBM service to have a view of who is connected to my database. I can also have a look to the records in my CRM. So in that case, I'm gonna just query a few things on the database, and behind the scenes, this is the data that is database that is used by my microservice-based application running on OpenShift. So in my case, I've got 10,000 customers in my CRM, and this is the data that is going to be used by the microservice-based application. And of course, if I update the record from my CRM, for instance, the key aspect here is that my CRM is synchronized in real time with my containerized based applications, right? So this is the point, right? So everything is in sync. So this is a basic JDBC integration, which provides real-time integration between my OpenShift based applications and my IBM core business applications. From the OpenShift portal, each microservice is a deployment. Each deployment contains several pods, and each pod can be one or several containers. So in that case, you see the different environment variables for this particular customer service with the IBM credentials or user profile to connect to the Db2 database. So the microservice is running, and this is the reverse proxy that is responsible for getting the request from the other services and connecting to the Db2 database and CRM application. And yeah, it does the link between the IBM world and the front-end applications. Let's have a look to the services. This is the IBM database service, which is used by the JDBC connection to connect to on the primary, I would say, one of the IBM nodes. And I've got the IBM database alt, which is the alternative node, because in that case, as I said, and I'm using the Db2 Mirror for I setup with a real-time active database, so CRM customer database on two IBM nodes, and the AcmeAir database, as you can see, is being replicated on the two nodes. And I mean, this is the Db2 Mirror for I user interface, and you can control what's going on. So you see the IP address of one of the nodes. I mean, it's the one that we use from the Kubernetes OpenShift service, and the second node as well for the alternate host used by JDBC. In addition to the application, I've got also a Jenkins running on OpenShift, and this is the deployment config related to the Jenkins application, which is containerized, and I've got this integration between Jenkins and OpenShift, so I can authenticate automatically with the OpenShift container platform, I would say registry, to the Jenkins application. So I'm logged into the Jenkins, and I've created a pipeline. So a pipeline is a way to automate different tasks on to IBM or to the containerized OpenShift world. So in that case, I created a simple pipeline that will be responsible, for instance, for after each application commit to automatically launch a Kubernetes OpenShift job, to automatically launch JMeter process. In that case, a job that is going to test the performance of the new application and validate or not the application version. So in that case, a simple pipeline relying on a Jenkins file somewhere on Git that's going to automatically deploy JMeter. And this is the JMeter, I would say, extension available on Jenkins. And automatically I will have the response times and percentage of errors after each commit, for instance. Just to illustrate what Jenkins is and what you can do, you can control, I would say, the code delivery using to IBMI or to OpenShift using open source technologies and third-party DevOps technologies available on IBMI, integrated with Jenkins. So while the Jenkins task is running, just created a job, a JMeter job, and you can see in real time that something is going on, and some microservices are active, and this is the CPU consumption in real time. A job has been created by Jenkins, and this job is responsible for running a specific pod container, and this container contains my JMeter script that's gonna simulate users connecting to the Acme Airline application. So this is the result of the performance test just run, for 5 minutes, and this is the response times per microservice, I would say, so this is a validated, I would say, deployment. The response time is perfect, and according to my objectives. Yeah, and the status is green, so it's validated, right? Yeah, imagine that I've got some PTF to install on a particular node. So I've just installed some PTF, so the synchronization between the two nodes is not active anymore, and so the first node is unreachable, and I can't write to this database. So automatically, as you can see on the screen, the connections are redirected during the load to the secondary node, right? So it's automatic. And you see on this screen that in real time you can see what's going on in the logs, application logs. In that case, Acme Airline customer service. So the virtual users are active and they are reading, writing in the flight in the customer database. In that case, customer database on Db2 so we are simulating a real workload with several hundreds of transactions per second. And yeah, as you can see on the screen, you can have a look to the number of bookings that have been done by the virtual users. Imagine that I've cut the synchronization between the two nodes at Db2 and I've got let's install a PTF, a set of PTFs on my one of the two nodes. In that case, I'm going to use Ansible. So using command line in that particular case, but I could have used the graphical user interface. I will see that in the next demonstration. In that case, I'm gonna check what's already present on the system, and I'm gonna install what's already needed. So a different way to use the Ansible, the PTF related Ansible modules available on the IBMI platform. So at the end, I've got my IBMI I would say at the latest version. So I can, and I didn't have to connect to my IBMI manually. I used Ansible to perform such tasks, right? Let's say that I've got an IBMI Cell 3, so in that case it's a dev and test environment. I want to create a new REST API, so this is a dev environment. For that purpose, I'm using the capability that IBM has to use the IFS as a repository for your ILE RPG COBOL code, right? So I've just compiled a program that I'm going to expose then using a REST API. So this is my VS Code. Again, as I said, I could have used RDI. This VS Code has some IBMI related extensions that are really of interest if you want to develop both on containers on IBMI. So in that case, I'm connected to my IBMI dev and test environment. I've got my RPG program on the right side, and what I'm going to do, I'm going to compile this code that is present on the IFS, synchronized with the Git repository, right? So it can be part, and this action can be automated through Jenkins, by the way. So let's do that manually for the sake of simplicity. So I can basically trigger a compilation action on the system, and I'm going to create a program object based on this source code that is stored somewhere in the integrated file system of on the IBM system, right? So this I've just successfully compiled my. Well, I'm not a skilled RPG developer, so basically this RPG code is going just to expose the customer table. So basically, you give an input, the user ID, and in return a JSON coming from the Db2 database. So I'm using a chaining. So select from where, I would say, to get the customer information. So this program is simple. It's deployed. It's compiled. Sorry. So what I'm going to do, I'm going to use the integrated web service server based on WebSphere Liberty to create a new web service that then I can use from my microservice-based applications. I mean, it's really an alternative to the JDBC connection. So in that case, the program is already compiled, right, in a specific library. So let's deploy a new REST API, REST Web Services. So in that case, yeah, I'm gonna use. So this is the library, and you remember I've just compiled the program, and the name of the program that was just created is it's get user info. It's a program, not a service program, right? In that case, next, just specifying a name. And and the parameter I want to give to this get, I would say, get a service. So in that case, it's automatically at compilation time generated a PCML file, and so I've got some. I mean, it knows the input and output of this procedure. And as I want this, I want a JSON return. So in that case, I just have to specify JSON, and I want the parameter, the input parameter, to be passed in the path of the query. So it automatically detects the UID and next, right? So it's really simple. I just have to specify the input parameter, output parameter, and that's it. And and I can add more information, but anyway, I mean, this is simple deployment based on an RPG program that I've just compiled using VS Code and the IFS, and this is my web service. So it's available running on the integrated web service server, so Java-based application server running on IBM. This is the Swagger specification of the API, which could be useful for if you give that to a developer. Developing, for instance, the front-end development, containerized based maybe. Yeah, and now my REST API is deployed, and I can test it. So I can give a parameter, for instance, UID 2, and this is the result I got from the database. And I can change the input parameter, etc., and the data. So okay, so this is, and then you can authenticate. And make this REST API more safe and secure using Nginx on IBM, or using an API management solution like Loopback available on IBM, or even Data Connect, and you can consume this REST API. This is an example of consumption of such API using from a mobile application developed with Cordoba, and this is another way to consume an application from a containerized base, or in that case it's a mobile application server, and I've got my mobile device connected to this containerized application server, connecting to this REST API on IBM, and I can have a look, for instance, to the user information, as I did previously on using the web version of the AcmeAir application. So just a different view, different containerized component in front of my IBM environment. And this is the list of flights, etc., available in my database, etc. So that's pretty it. I hope you enjoyed this demonstration. I try to quickly illustrate what you can do today on IBM using open source technology on IBM, but integrated also some containerized based components running on OpenShift. Thank you very much, and talk to you soon.